An algebraic fraction can be broken into smaller parts called partial fractions. In this video, we'll explain how this process is carried out. In this example, we can clearly see that the component parts must have denominators of x plus 2 and x minus 3. So we can equate the expression to a over x plus 2 plus b over x minus 3, where a and b are real numbers. Next, we need to get rid of the denominators from the equation. So we multiply each term on both sides of the equation by the common denominator x plus 2, x minus 3. We can now cancel the common factors from the numerators and denominators of each term. On the left, we are left with 4x plus 3. On the right, we'll end up with a times x minus 3 plus b times x plus 2. The objective is now to find the values of a and b. This can be done using several methods. An effective method is to substitute x values into the equation, which is an identity. This means that we can substitute any value of x into the equation. However, we will choose values of x that will make the brackets 0. Let's first substitute x equals 3. This means we'll replace x everywhere in the equation with 3. So, on the left, 4x plus 3 becomes 4 times 3 plus 3. On the right, x minus 3 is now 3 minus 3. In the second bracket, x plus 2 is now 3 plus 2. On the left, 4 times 3 plus 3 is 15. On the right, 3 minus 3 equals 0. And a times 0 is 0. So, all we are left with on the right-hand side is 5b. So, 15 equals 5b. Now, divide both sides by 5, and we get b equals 3. Now let's go back to our identity equation. This time, we will let x equals negative 2. On the left, it's now 4 times minus 2 plus 3. On the right, the first bracket is minus 2 minus 3, while the bracket will become minus 2 plus 2, which cancels to 0. 4 times minus 2 plus 3 is minus 5. Minus 2 minus 3 is also minus 5. So, 5 equals negative 5a. So, solve for a, divide both sides by minus 5. So, a equals 1. So the original expression written in partial fractions is 1 over x plus 2 plus 3 over x minus 3. In the second example, we have a situation where the denominator has a quadratic term that cannot be factorized. So we equate the fraction to x plus b over x squared plus x plus 2 plus c over 2x minus 1. When the denominator contains a quadratic factor, we have to consider the possibility that the numerator can contain a term in x. Note that the numerator would still be of lower degree than the denominator, so this would still be a proper fraction. The next step is the same as before. We multiply each term on both sides of the equation by the common denominator. So times both sides by x square plus x plus 2 into 2x minus 1. On the left, we are left with x square minus 3x minus 7. On the right, the first fraction simplifies to x plus b times 2x minus 1, while the second fraction simplifies to c times x square plus x plus 2. We need to now calculate the values of a, b, and c. Now let's substitute values of x that will make the bracket 0. For the brackets with 2x minus 1, x equal to half will make the bracket 0. By the way, to know what value of x to substitute, you can equate the brackets to 0 and solve to get x equal to a half. Now let's substitute x equal to half into the identity equation. On the left, x square becomes half square. Minus 3x is now minus 3 times half. On the right, a times x is now a times half. And then c times half square plus half plus 2. You can just use a calculator to compute the value on the left, which simplifies to minus 33 over 4. On the right, the bracket simplifies to 11 over 4. Times both sides by 4, we get negative 33 equals 11c. Divide both sides by 11 and we get c equal negative 3. Now there is no other bracket in the identity equation that we can substitute an x value to make it 0. So we just have to substitute other x values. We can use any value of x. However, to keep the calculation simple, we substitute the smallest possible values for x. Let's substitute x equals 0. Only minus 7 will remain on the left. On the right, a times 0 is 0. Also, 2 times 0 is 0. So we get b times minus 1. Recall that the value of c is minus 3, and inside the bracket will simplify to just 2. So now we have negative 7 equal minus b minus 6. Add 6 to both sides, and we get minus 1 equal minus b. Divide both sides by minus 1 and get b equals 1. We still need to find the value of a, so let's substitute another small value of x into the identity equation. Let's try x equals 1. On the left, we'll get 1, minus 3 minus 7. On the right, recall that b equals 1, so the first bracket will have a plus 1, while 2x minus 1 will simplify to 1. On the far right, replace c with minus 3. Inside the brackets will be 1 plus 1 plus 2. The left-hand side will simplify to minus 9, while on the right, we'll now have a plus 1 and minus 3 times 4, which is negative 12. Group all the constants on the left, and we get a equals 2. To get our final solution, we replace a, b, and c with 2, 1, and minus 3, respectively. In the third and final example, the denominator has a repeated factor x minus 1, all squared. There are 3 possibilities for a denominator in the partial fractions. They are x plus 2, x minus 1, and also the possibility of x minus 1 all squared. A, b, and c are all real numbers. As in all the previous examples, we multiply both sides by the denominator here on the left. This will leave us with 3x plus 1 on the left. On the right, we get a times x minus 1 square, then b times x plus 2 into x minus 1, and then c times x plus 2. Again, we look for x values to substitute into this identity equation that will make the bracket 0. If we let x equal 1, the left-hand side will be 3 times 1, plus 1, which is 4. On the right, the first 2 brackets will be 0, making a, and b disappear, while the last bracket will be c times 1 plus 2. So we get 3c. To solve for c, we divide both sides by 3. So c is equal to 4/3. Now let's substitute x equal minus 2. On the left, we will have 3 times minus 2 plus 1, which simplifies to minus 5. On the right, the second and the last brackets will both have minus 2 plus 2, which is 0. So b and c will disappear, leaving us with only a times minus 2 minus 1 all square, which is minus 3 all squared which is 9. To solve for a, we divide both sides by 9. So a is equal to -5/9. We now need to find the value of b. There is no other value of x that will eliminate a and c to give us b. We could use any value, so let's use x equals 2. So on the left, it's 3 times 2 plus 1, which is 7. On the right, 2 minus 1 square is 1, so we get a. Then x plus 2 times x minus 1 will be 4 times 1, so 4b. The final bracket will be 2 plus 2, so 4c. Now we already know the values of a and c, so we plug them into the equation and get 7 equal -5/9 plus 4b plus 16/3. To solve for b, we can group all the constants on the left. So the equation simplifies to 20 over 9 equal 4b. Divide both sides by 4, and we get the solution b equal to 5/9. So we can now write our final answer by putting in our values for a, b, and c. Partial fractions are essential in calculus for integrating rational functions, as they simplify complex expressions into manageable terms that match standard integration forms. They also play a crucial role in differential equations, Laplace transforms, and algebraic manipulation in advanced mathematics and engineering applications. If you like this video, give it a thumbs up and subscribe that you can be notified of new uploads. See you soon.